Hello everybody, welcome back to the shop in the F-14. Panel we laid up yesterday, right here. I haven't taken out the bag yet. The only thing I've taken off is the vacuum connector and the bag closure. One thing I do to make finding the vacuum fitting easier, since I don't have a billion of these things laying around, because they're kind of pricey and really I don't do it like 3 or 4 parts at a time anyway. What I do is I will, before I take the fitting out, and zoom in for you guys. What I do is I'll draw a circle around it, and then I'll put a little arrow, and then from the arrow I'll make an A, as you can see from there. And what that'll do is it'll help you find the little plus cut in the bag the next time you go to reuse the bag, if you plan to reuse the bag. Like I said, these are bag tubes, so it's just a big long piece of double-sided thing, and the edges are sealed. So I'm trying to reuse these as much as possible. If they start leaking at like one end of it, like really badly, what I'll do is I'll trim the bag to get rid of that leak, and then I'll throw that part, the excess part, away if there was a lot of leaks on it, or I'll try and use that part for a smaller piece, and I'll I'll close up one end with sticky tape or whatever. I try and reuse this stuff as much as possible within reason. I mean, it gets to the point where eventually they leak too much, or they're so small where it's just throw it away. I think this 36-inch wide bag was about $4 a yard. The 60-inch bag tube is like $6 or $7, $8 a yard. And then the 18-inch tube, which I haven't even cut one of those out yet, I don't think, is like $3 or $4 a yard. Anyway, enough of that. Got word from my machine shop. All of my parts are done, and they'll be shipping out today via FedEx. So if all goes well, I should have them, oh man, Wednesday of next week. Which means I gotta order materials for tires this week, so I can lay up 2 tires for that thing when the mold shows. Which, since I make my own tires, yes, I make my own tires, I'll show you guys what I use for that stuff. I'll show you what I have been using and what I will be using. Because the stuff I'm gonna try in the F-14 tires is a different style material than what I've been using for like my F-18 tires and my Durjet Cougar tires. Which I'll show you guys some of that stuff in another video that I'll do right after this one. But the stuff I'm going to try using is expanding urethane foam that self-skins. So it'll look like rubber, but it's actually the foam. The company I get that stuff from is called Smooth On. They've got a huge list of stuff. They've also got like a 2-part urethane rubber that's a solid rubber. I used to make a set of tires for the yellow aircraft at F-18, which I still do. I just have to remake my molds. Again, I'll show you that in the next video. But I was using a 2-part rubber for that, and the tires are extremely durable, but they're also extremely heavy because it's a solid rubber tire. I think the first durometer material I used was a 90 durometer, and the first guy to get a set of those, other than myself, dropped a tire and a rim combo, and I think he said it hit his toe and it felt like it broke it. So don't use a 90 durometer rubber for airplane tires. It's literally like a hockey puck. The second material I used, which I only did 1 tire of that, was a 30 durometer. They were just way too soft. After that I went up to a 60, and the guy that was testing those out for me said they worked really well. They just expanded with the speed of the airplane. So I got to call the company and see what they have or recommend to get rid of the expanding issue. He said other than that, having to glue the rubber tire to the rim, he said the things work phenomenal. They're extremely durable, much more so than the foam tires you get with the stock rims and tires with the yellow aircraft F-18 kit, or the stuff they sell. But again, one of those things. The tires that I have for the F-18, they do fit the stock F-18 rims, and I just do the mains. I don't do the nose wheels. The nose wheel tires don't really wear out all that fast, so there's really no point doing it. Plus, the price of the mains to do a set of nose wheel tires, to me, about the same price as a set of mains, they'd be like $20 cheaper or whatever. So anyway, pulled up my bag here so I can get it out of the way, put it back up on the shelf. Which, speaking of shelves, I need to put more up. Never have enough storage, it seems. But you can always have too little. You never figure it out until you need more. Well, since I folded it the wrong way, it's just gonna be a big pillow, which is fine. Oh, if anyone's interested in a brand new in-box Sato 200 twin inline, literally brand new, I've got one that's a buddy of mine's for sale. It's brand new in box. There's a twin cylinder. I think it's a CNH ignition. We were going to convert it over to gas and never really got around to it. He's decided to get out of the giant scale RC stuff, so he asked me to sell that. I've also got a Dave Anderson Auto AR96B kit with, it's a full kit from Precision Cut Kits. The fuselage has been started, the tail section built. I got that for sale also for him. If anyone's interested, shoot me an email. That motor is like $900 brand new, and I think the ignition system was like another $150, $200. So I mean, it's like $1,000, $1,100 for the motor and the ignition. He didn't tell me what he wanted for it, he just said sell it. So if you're interested, send me an offer. I'll run it by him. Maybe we can all help each other out. Perforated plastic and the bleeder material all kind of come off at once. Bleeder material can go in the trash. Perforated plastic, really, if you didn't put a hole in the middle of it, hold on to it, reuse it. Especially these big pieces. I mean, like this little corner over here, I tore it, but you know, this stuff's not super expensive, but it's still expensive at $3 to $5 a yard. So I mean, there's no holes in it. Reuse this stuff. Save your ears a little bit of a tongue lashing from the Mrs. or Mr. depending on whatever, and save your wallet and your bank account some hemorrhaging. I got a box of this stuff. I'm like, oh, I'll reuse that, and then when I get ready to lay up another part, what I do, I just go and cut another piece off instead of reusing what I got. So one thing I'm planning on doing is getting a bunch of small boxes and labeling the boxes, the sizes of these things, or what they'd be good for. Like, here's something for stabs, or here's something for nose combs, or whatever, just to kind of organize the stuff. Alright, so we're done. No, I'm just kidding. Got the peel ply off. Peel ply is always the fun part. Especially on a big panel like this with so much surface area, it's hard to get the stuff off. Just kinda gotta work at it. stuff I'm using for fuel ply is not the fuel ply you would get from like ACP Composites or any place. It's actually it's just a polyester dress liner. It's 100% polyester. I actually get this stuff from Walmart for like $1.25 a yard. And it works fairly well. It doesn't release quite as easy as the real fuel ply stuff. But for the price difference, I mean, this stuff's like a half or third the price. I'm alright with that. Save some money for a little bit extra work. That's the same material I use for glass and wooden airplanes as well. Side, so there's one little piece that doesn't want to come off. Well, we'll do that side here. Fix that in a minute. Alright. Other side. That piece of plastic that was on the table. Look how nice and easy that peels off, man. And this stuff, believe it or not, is just a real heavyweight plastic drop cloth from Home Depot. You can use this stuff for a vacuum bag too if you wanted. It's cheap. I think 25 foot by 100 foot rolls like $3, $5, something like that. You get this real heavy stuff that's kind of semi-opaque. I mean, you just saw how easy it peeled off. It was just like butter. But you can use that for a vacuum bag too. I've done that quite a bit. Heavyweight trash bags work really well. The only downside is you can't see through them. But otherwise, other than that, as long as this is a big, thick piece of plastic that doesn't have holes in it, you can use it as a vacuum bag. It really doesn't have to be that thick. Like some of the earliest parts I did, like the ventral fins, that first ventral fin I did, I just used a regular trash bag for that. Trash bag and some acrylic bathroom caulk. Like the cheapest caulk you can get was like $1.25 tube from Walmart. Use that to seal up the ends of it. Throw your part in there, and your layup and all that stuff. Put your vacuum bag fitting. Throw you some caulk on the open end to seal it. Suck the vacuum to it. There you go. You got your vacuum bag for like $1.50. put in the bag over there, the one layer of glass in the very bottom kind of rolled over and took itself off the surface. But that's okay. There's always a little corner that you're not going to be able to get apart in completely. So I'm not too worried about it. Yeah, it sucks, but oh well. So I'm just going to take a nice sharp chisel here and just go around and trim that off. Same thing down around these edges. We'll just take a chisel right down along the edge of the panel. All I'm doing is just trimming off the excess glass with a regular old wood chisel. Nothing fancy here. Yeah, you probably put it in a table saw or whatever and put it down real nice, but I don't have a table saw, so I'm going to do it this way. Again, for those who didn't watch the video where I laid this up, what this is 5 layers of glass. You got 2 on the surface, which goes 90 degrees, 45 degrees. Then you have a layer of 4mm RX C7055. Then you have another layer of glass with 0 to 90 to the long side. Another layer of 4mm RX. And then you have another layer of 45-degree bias fiberglass, and then a final layer of 90-degree bias fiberglass. It's 3 ounce per square yard of glass is what I use for all the layers. For those wondering about that. So there's 15 ounces per square yard of glass roughly. Plus, of course, the weight of the panels and resin and all that good stuff. Alright, there we go. There's our 8mm thick RX panel. How strong is this thing? Well, you can see you can pick it up from one end to the other with other end sitting there doesn't bond. I mean, you can push on the middle of it with a good bit of force without it really bonding much, and then twisting for me. You see it doesn't twist a whole lot either. So, I thought you guys are going to use this for some of the secondary structure. Wondering what the heck is secondary structure. So, what I shall do, get this one last little piece of peel ply off. What I do is I just take my chisel and go up against the edge of it real gently. There we go. Till you get the edge of it and it comes right off. Alright. Secondary structure. Basically, primary structure in this airplane is going to be the center box bar for the wings. Which the plug is right here. I've actually got a coat of primer on it. That's the box bar plug there. And basically what this does is this gets epoxy just like that to the top of the fuselage. And this will all be attached with high saw, man. Speaking of high saw, I'll show you the biggest high saw gun I've ever seen here in a moment. So that gets attached to the top part of the wing skin, or the fuselage skin. Somebody asked me something on YouTube about that, and I forget who. I forget what the question was too, but anyway. This gets high saw to the top of the fuselage. The outer brackets, they were asking me how they get attached. Well, with this attached here, the brackets actually have a couple of bolt holes in them. See, here's the pivot bracket, and that's the face that goes up against that piece of carbon. You see it's got 5 holes in it. Why 5? The center one gets put in first, and this bracket pivots around it. This center hole is right in the middle of the axis for this. So you put the center one in, which I'll actually have all this pre-done by the time the customer gets the airplane. But the center bolt goes in, the box bar is already attached to the fuselage top, and it already has the center hole drilled with a bonded line nut on the back side of it. There's this huge piece of 3/8 plywood that'll go inside the carbon box to hold that blind nut. So that'll all get bolted on. You go in there, the fuselage mold will get leveled with the fuselage in it. And then what I'll do is I'll preset the wing incidence. Once the wing incidence is set, these other 4 holes in the corners will get drilled. And then I'll have a small little access hatch right in here, just big enough. Get a finger and a magnifying glass and stuff in there. You can put the other 4 bonded washers in the parts. Once I get this first one done, I'm actually going to have a fixture made to where all the bonded washers and everything will get attached to this before it even gets epoxied into the top of the fuselage. So every wing incidence will be preset identical to the first airplane. That's how that's going to get attached, and this actually gets attached with I believe they're AN4 aircraft bolts, high tensile aircraft bolts, and they're expensive. They're like $7 or $9. I think about $11 a bolt for the high tensile strength ones. All because they have a little special washer that has to go on here that has a little bitty curve in the head of the bolt, and then they're internally wrenching as well. So it's kind of like an expensive Allen bolt. Is basically all it is. So that's how that gets bolted to that right there. So that gets pops or high sawed in, and then there's also 2 bulkheads that are carbon fiber reinforced on both sides that go from the bottom of this bulkhead to the bottom skin of the fuselage, the full width of it. So that's what ties this to the top and then this structure to the bottom of the fuselage. So this whole section right here where this box and those 2 bulkheads meet is going to be one hefty piece of layup. And again, if everything goes well and goes as planned, this will be the strongest part of the airplane. This and the whole pivot mechanism interface. Just like the real one. I don't want this thing to go anywhere. And if it ends up being way over strength on this one, I can always pull a little bit of material out. It's always easier to make something lighter on the second one than it is to try and make the first one too light and make it weak. Alright, so that's that structure. As far as the nose gear structure goes, there's not a whole lot to show you, but nose gear structure, really there's not a whole lot. There's going to be probably 2 or 3 parts to the whole nose gear assembly, and that's it. You can have the forward bulkhead that the nose gear retraction and everything will attach to. And then depending on whose nose gear and system I use, it'll either have a vertical one and then a second vertical with a flat plate between the 2 to kind of tie them together, or it'll just be that one, and then I'll have 2 triangular braces that go back along the back side of the fuselage to sit there and help support that vertical bulkhead wanting to move forward and aft into the center. So that's on nose gear structure. Coming back here to the tail, what we have is just two little bosses that are pre-molded into the fuselage top. And what we have two 3/8 diameter solid carbon fiber rods. They go into these pre-done bosses. And these bosses are actually setting the outward cant of like 4.5 degrees for the vertical fins. It's all preset in the mold. We have the pivot shafts here for the horizontal stabs. They're pre-molded in there, so when I get my aluminum machine parts and I get the mounting bulkhead for that done, the pivot shafts are going through here. The pivot shaft support structure on the inside for the whole mechanism to go in. I have one bulkhead, full width again laminated both sides with carbon fiber, and a ton of lightning bolts to keep it light. That'll go in place, and that's basically your support structure, the first part of your support structure for your horizontal stab actuator mechanism and your servos for that. Just after that, I'm going to have two partial bulkheads. They go right behind where these carbon spars are going to go. And on the inside of these carbon spars, there's two axially woven carbon fiber tubes that will get, again, isol to the skin of the fuselage. This bulkhead will go right here, which is also the integrated mount for the rudder servo. Two rudder servos, one here and one over here. And then there's going to be two more plywood pieces that run from this half partial bulkhead to the full width bulkhead that sandwiches that carbon fiber tube in place. The whole name of the game on this back side of the fuselage is twist. You got to get rid of as much twist as possible. At the full-scale airplane, when they had those big clamshell doors under the engines open, the airplane physically could not be moved from its position until those doors were closed and fully latched and attached, because the airplane would actually, the whole back of the fuselage would sit here and flex along the back, because those doors for those engines are actually structural to the fuselage. Same thing, I want to get as rid of as much twist. Granted, I'm not going to have those giant doors back here, but I still want to get rid of as much twist back here. These horizontal stabs are huge, and when you got those wings swept or unswept, you sit there and you get 10, 15, 20 degrees of deflection on both of them, and they're trying to make the fuselage wrench to the side. You gotta have this thing really strong. That's why I've got Eric's on everything on this fuselage. So full width bulkhead here, partial bulkhead, sandwiched on both sides. This whole structure back here, along with two partial bulkheads up here, that only go to the center of the spine here, and then this whole horizontal stab mechanism that has the servo mounts integrated. This thing right, get close to that there. Basically, let me zoom in on the fuselage and I'll show you guys a little bit more of this. This is all machined out of aluminum, 6061 T6. So basically, this is going to be in here just like that. Full width bulkhead on the backside that also intermingles with this carbon spar that you see. Full across, partial bulkhead, rotor servo, all that good stuff. There's another bulkhead that goes right here in the front that runs straight across. That's a full bulkhead that goes from the top to the bottom. Originally I was just going to do a small one right here just to support this, but the more I got thinking of it, if anything were to ever happen or you lose a screw or something, this whole thing's going to want to turn. So if you sit here and support this a lot better or more firmly, it'll hopefully it'll resist some of the twisting enough to get the airplane back on the ground until you can figure out, like, holy crap, my stab's loose. So anyway, there's that, partial bulkhead. So here we got two partials, one full, or two pairs of partials and one full bulkhead. Down this center part is where this whole plate comes into play. From this partial bulkhead, well, actually from this forward bulkhead all the way forward down the center spine, right along the edge of the nacelle, I'm going to have two vertical spines cut from this Arex plate we just made up. There's going to be one on this side on the inside of this nacelle and on the inside of this nacelle. And they're going to run from this full width bulkhead all the way forward to this aft wing spar support bulkhead. So not only is it going to connect this bulkhead and this bulkhead, that's 2 full bulkheads. You also got this 1/2 bulkhead, and then there's another full bulkhead that's going to run basically right here. And that again is also full width. And this is one of the main structural members for the main landing gear. That's going to sit there, and you have one bracket. It's basically going to be a 90 like this. You're going to have one portion of the main gear here, and then there's going to be another 1/4 inch plywood, 3/8 plywood, laminated with carbon fiber. It's going to run parallel to this center spine and connect with this forward wing spar support bulkhead. So you're going to have this huge 90-degree triangulated carbon fiber bulk of carbon fiber reinforced plywood. Everything's aircraft grade plywood. I'm not doing like ply or any of that chintzy Chinese crap. It's all 7, 10, or 12 ply plywood, or 11 ply, whatever it is. Anyway, I have this huge triangulated piece of stuff right here. That's all going to be glass and carbon fiber to the fuselage skins. Everything's high sawed in place. This whole system right here is this huge engineering thing that I've got in my head. I've done all the CAD drawings already for all this internal structure. I've done all the stress counts. Even without these skins and the stress count, one of these, this structure right here, just out of plywood, is going to hold about 300 pounds of force before it fails. And that's straight plywood. That's no carbon fiber onto it. So I mean, it's extremely overbuilt, but you're going to be able to plow this thing onto the ground without having to worry about breaking it. And that's all 1/4 inch plywood too. So again, I mean, guys are thinking I'm just trying to up the hype. I'm not upping the hype, guys. I mean, I told you, not doing a lot of building right now because there's not a whole lot to show for it, and I can only show soft epoxy so much. But I'm getting there. Once I actually get to where I'm actually building something, I'll be doing a lot more of these videos on the actual building, because potential customers, I want them to know that I'm building this thing like a modeler. I'm not going to build it like somebody who's going to sit here and wants to make an extra $100 by using the next thinnest grade of plywood or balsa or the next cheapest material. I'm building it to fly it and to sell it. If I'm not happy with it, I'm not going to sell it. Simple as that. So that's where we're at on all the structure. Figured you guys would like a little bit more in-depth visual on the structure and everything. Our little AirX panel with all that, the purpose of that for. I gotta make another one of those. I'm not gonna bother doing a video on it. It's the same process. It's just 4 layers of glass, 2 on either side of a single piece of core material instead of 2 pieces of core material and glass. But yep, that's where I'm at. Oh yeah, the giant high saw gun. I think you guys will like this. Oh man. To get it out of the machine here. Alright. This is your typical high saw hobby gun. Now you're paying for size comparison. 50 milliliters, like 1.5 ounces. Well, 1.7 ounces of high saw. That's my new high saw gun. little dinky. And then when see if I can remember how to use this thing. There we go. I mean, actually pulled the mixing nozzle all the way out. I mean. Just the mixing portion of the new high saw gun is about the size of the other high saw gun. So what the heck do I need a high saw gun like this for? This thing holds 200 milliliters of high saw at a time. So I mean, you figure 1.7 ounces, 3.4, so almost 7 ounces of high saw. If everything's gonna be high sawed in, you gotta have the right tools. This comes like 400 bucks. It's an eBay find, $75. I gotta love eBay when you find good deals. So Wondering how much a 200 milliliter tube of Isol cost? That tube is like $17. A 200 milliliter tube's like $65. And I probably use 2 tubes per fuselage is what I'm thinking. But yep, that's it. That's the giant Isol gun. That's the fuselage. That's the AirX panel. That's all I got for really this day and age. I'll pop out some of my tire molds and I'll show you guys that stuff for those of you interested. Anyway, until next time, which is a couple minutes. Y'all have a good one. See you back in the shop.